So we're going to start off with what is elastic computing. We're going to talk about EC2 later, but let's talk about what is elastic computing. And I've dropped hints here and there about what it is and about the scale up and the scale down capabilities. But what I want to do here is let's kind of visualize it. Let's try to understand it because it's very important to understand elastic computing. It's the fundamental building block behind AWS and behind cloud computing in general. So if you understand that elasticity, you're going to be just fine. Now, what I want to do here is also take a use case, and I'm going to take a real world use case. I don't know if you guys have heard of this company called DollarShaveClub.com. DollarShaveClub.com is a company that offers razors, right? So instead of you going to the supermarket or wherever you go to buy your razors, they'll ship you the razors that you need for $1 a month. Now, let's assume this was your organization. And within your organization, you've established that, in order for you to run your current business the way it's running, well, you need to have a capacity of about 100 servers. So let's establish that as our baseline. Now, as with any other organization, you're going to have, ups and downs as far as workloads and as far as capacity is concerned and as far as performance, right? So it's going to look something like this. Sometimes it's up, sometimes it's down. Sometimes you need all the servers, sometimes you don't, etc., etc. Every once in a while, what's going to happen is maybe you'll get a spike where the need or the load has exceeded what your maximum server's capacity can deliver. That's that red that you see over there. That's okay. Someone is calling, someone is complaining, the performance is slow, customers can't purchase off of your website. Whatever the case might be, that's the red, because again, you've gone over your capacity. And maybe it was, I don't know, Christmas, and as a result, that capacity went through the roof for the first time. Now, after Christmas passes, what happens is, well, it goes back to fluctuating, right? So again, it went down. But during that peak, that red made your management nervous. Your management came and said, hey, what's up? We're always, we're going to be growing. Christmas is gone, but we're going to have other events, so on and so forth, right? So we need to be prepared. So what do? Well, you tell your management, hey, in order for us to avoid that spike, we need to make another purchase. We need to increase the capacity that we have in order to support, those fluctuations. So what you do is you raise that baseline. So instead of being at 100 servers, you now have raised that baseline to 200 servers. And as a result, your load has increased. Maybe you've done some marketing. And as a result, okay, well, the load on your servers, your load in general, has gone up, but now you've also doubled the number of servers. You've made a huge capital investment there. So you're fine for a while, and that load keeps going up and down. Now, the problem is, with this particular model, not only is it expensive, because every now and then you have to kind of essentially double or add more capital investment, over provision your environment so that you don't get into that situation of that red bar that you see there. You need to always over provision. Over provisioning means that you're buying resources that you don't need immediately, which means you're paying money for stuff you don't really need today. Now, the other idea behind elastic computing is, if you can see all of the purple that I've just painted, that's unused capacity. That's capacity that you've purchased. And even when you were at 100 servers and at 200 servers, you're not using that all the time. So it's sitting there doing nothing. If most of the time you're using 50 servers or 80 servers, and every now and then you pop up and your capacity requires more and you don't have it. But for the most part, you have over-provisioned capacity that you don't need. So with elastic computing, that's what we're trying to avoid. We're trying to give you the ability, if you need 100 servers today, that is what you need, then don't over-provision. Just provision 50 servers. If tomorrow you need 100, then provision another 50 more. What does that do? That allows you to save the CapEx. That saves your business a lot of money because, again, you're not putting up that upfront cost. And remember, that upfront cost is not just about servers. It's about servers. It's about the man hours that you put in to configure, to rack stack these servers. It's about the facilities, the cooling, the heating, the networking gear, the ports, the storage, all of the things that are required, the licensing for the software, everything that is required in order to bring those up. And if you're not maximizing on their usage, well, they're going unused. Well, why do that? If you use cloud computing, then you only provision what you need. You never over provision. Why? Because that capacity is always available to you in order to provision whatever you want. Now, let's complicate this scenario a little bit more, because you're probably thinking, well, I understand what you're saying, Eli, but we've managed. We've managed so far. Okay, great. What I want you to visualize, and this actually happened. Now, I don't know if the scenario that I'm giving you actually happened, but DollarShaveClub.com released a YouTube video. It's a pretty cool YouTube video. If you haven't seen it, you should go out and to YouTube and watch it. And that video got, I believe, over 18 million views. So what does that do? If DollarShaveClub.com was at 200 servers before they released that YouTube video that went viral, what do you think happened after that YouTube video hit? Well, guess what? They probably got a lot of sales from it. Now, what if Dollar Shave Club knew in advance that, okay, we're about to release this video and this video is about to go viral and we need to be ready for it. So, hey, IT guys, you need to be ready for this. And the IT guy's like, well, how ready? Like, well, we don't know. Let's just, let's double the capacity that we have. So instead of having 200 server baseline, you went to a 400 server baseline. Okay. Now, what ended up happening is once that YouTube was released, that baseline went up to 500 servers, which means you, with the provisioning that you did and the over provisioning that you thought you had done, you went up to 400. You doubled your capacity. But because this is an unpredictable thing, there's no way you can tell, the response that you're going to get from your customers to this ad campaign that you're running. In this case, it went up to, and I'm going to simplify this. I could have set 5,000, but you were required to have 500 servers to support the load for that marketing campaign that just went out. Now, if this was a real world environment, what would you have to do? Well, guess what? You would have to order servers. And those servers would have to come in and rack stack, and there goes 2 weeks before you can be live, right? Well, guess what? In 2 weeks, your customers aren't going to wait. Not only have you lost customers, but you're not getting the return on investment from that marketing campaign that you put out there. So unless you went crazy and ordered 5,000 servers just to be on the safe side, and then the load came from the campaign at 2,000 servers, and you've over provisioned by 3,000 servers, that means you've still lost. You see what I'm trying to get to? The idea here is you can't really pinpoint how many servers you need when in the age of the internet, in the age of YouTube, in the age of the startups and the .coms, if you're working for them, or if you're not working for them and your company releases a campaign. Well, but how much would you provision? Are you going to double your sales? Are you going to triple your sales? Quadruple? Who knows? 18 million views. Well, that's going to be a lot of servers. With Elastic Compute, if you provisioned for 200 servers and you need another 500, guess what? You can do that immediately. With the click of a button, you can provision those. Sure, you have to notify Amazon and go through some process because you're provisioning a large amount of servers, but it's immediate. It's not 2 weeks. You can respond quickly. You can even over provision, but throw out an outrageous number, and then once that ad hits and you know approximately where your load's going to be, well, then you provision accordingly. So what happens with Elastic Compute? Well, with Elastic Compute, now you have the ability to scale up to 400, 500 servers, whatever the case might be. With a traditional environment, right, you would have gone up to those 400 and 500 servers, and you would have gone back down again, and so on and so forth. So the idea behind elasticity, which is what you see in the green on the right here, is you can scale up when you need to scale up to 500 servers, and then scale down when you don't need the 500 servers and you need maybe just 300 or 250 servers. You can do that on the fly. You can avoid the CapEx expenditure. Now, I gave you the idea of Dollar Club or DollarShaveClub.com as an idea because the video just went viral and it just gave me this idea of showing it to you. But you can do this with pretty much anything. Anytime you're trying to have a large jump in capacity, whether it's from 200 to 500 or 200 to 5,000, whatever it is, that large jump is going to be very costly, especially when you don't know how many servers you need, and especially when you don't know where that load is going to settle at. So yes, there's a spike that happens, but where will it settle? So the DollarShaveClub.com commercial went viral, and oh my God, we're getting bombarded with orders. But a month later, these orders are going to stabilize at a particular threshold. If you've over provisioned, what do you do with these servers? And if you've under provisioned, well then again you're losing money either way. There are several use cases where elastic computing can be useful, right? Whether it's mergers, whether it's new product launches, new marketing campaigns, new applications. There's a lot of use cases where it's unpredictable and hard to keep up. And the idea of over provisioning in today's world of spending that capital on something that you may use all the time or may not is going to continue to become a very difficult proposition to sell to the business. What if it's a new service? We failed to mention that. So it doesn't have to be just a new application. It could be an entirely new service that you're offering as well. Now, Dollar Shave Club is not the only use case that's out there. If you're curious about, well, who else is using Amazon Web Services? I have something of interest to you. So there is a website specifically dedicated to the customer successes that are powered by the AWS cloud. Now, if you visit this website, and I'm going to take you there just because I find it interesting and fascinating to show this to everybody that I talk about Amazon Web Services with. So on this page, you'll find customer success stories that are powered by the AWS cloud. And you'll find some pretty big names out there. You know, Netflix is a huge one that leverages the Amazon infrastructure. Oh, and there it is. For video streaming. You know, you got Adobe, you got the Dow Jones, you got Citrix, you got the FDA. I mean, these are pretty big names. The CDC, Nokia, Pfizer, Foursquare, I mean, Lionsgate, Comcast, talk about video here, Hess. I mean, there's a lot of companies out there that are leveraging AWS as a resource. Now, they could be using it for everything. You know, Netflix could be an example of that. Back in the day, they were using Amazon Web Services entirely, completely. Dropbox is using it. Pinterest is using it. A lot of the startups are using it. But if I scroll down this list, you might be like, this is a pretty short list. Well, check this out. From this drop down on the left here, you can select the use cases that you want to display kind of by vertical. What I like to do though is select view all and click on go. I can be scrolling here for a while with some of the use cases that you can find of customers leveraging AWS. And you're going to find customers across all different types of verticals. So regardless of the vertical that you're in, if you're trying to figure out if Amazon Web Services is a good fit for you, you should scroll down either this entire list or narrow it down by your vertical. Now I can keep going. Now you've noticed how long I've been talking and I'm still scrolling down here. So there's a lot of customers that are using AWS. So as you're thinking about this, as you're trying to position this for your management, if management is not entirely bought in just yet, make sure that you're taking a look at these use cases. Find a company that's similar to yours in the same industry and take a look at what they're doing in order to help justify what you're trying to accomplish as well. So let's start exploring the global infrastructure that makes up Amazon Web Services. There are certain lingos, certain terms that you have to start getting familiar with. Regions and availability zones being one of them. Now, what's a region, Eli? And what in the world is an availability zone? To simplify it, a region is a geographical area that Amazon specifies. An availability zone is a data center within that region that Amazon has. So for example, and this is strictly hypothetical, on the US East Coast, that could be a region. On the East Coast, Amazon might have a data center, for example, in New York, and maybe they have a data center in Atlanta. And this is just figuratively, they may or may not have that. We're going to talk about where those data centers are a little bit later. But the idea is a region is a geographical area. So for instance, you have US East and US West and maybe US Central. And an availability zone is a data center. The availability zone has to be within a particular region. And within every region, you're going to have 2 or more availability zones, which means 2 or more data centers. Now, the global Amazon Web Services infrastructure has multiple regions that scale the world, and they have multiple availability zones. But the idea here is to show you, again, what regions mean and what availability zones mean. Now, the interesting thing and the thing that you should note is within every particular region, within every particular availability zone, certain services may or may not be available. And I'll show you a little bit later on where you can go to figure out which services are available in which region and which availability zone, etc. But the idea here is for you to understand that not all of the Amazon Web Services are available in all the regions across all the availability zones. Amazon may release certain services in regions before they release them in others because they're more reliable or that region is older. For a whole slew of reasons, you might see certain services that are available on the US East Coast, for instance, before they're available on the US West Coast. So keep that in mind because that might be a factor in where you place your services. So if you're trying to build a presence, maybe some virtual servers or instances, and you need to figure out, well, should I put those in the US East region or the US West region? The type of service that you're looking for may help dictate where you end up placing these resources. So keep that in the back of your mind. So again, regions are a geographical area. Availability zones are data centers within that geographical area. So those are two important concepts for you to understand, important lingos, essentially, Amazon lingos that you need to be aware of. Amazon or AWS edge locations. As you'll see on the map here, everywhere there is a yellow dot, there is an Amazon AWS region. So you'll find that there's a few in North America, there's South America, Europe, you've got Asia, you've got Australia. So they've covered the globe, right? But everything that's a blue dot is an edge location. Now you'll see that there's plenty of edge locations. Now what are edge locations? Edge locations are services that Amazon offers that are complementary services. They're not services they're not something where you can place a resource in. So you can't take an Amazon instance, essentially a server, and place it in an edge location. That just doesn't work. But you can consume services that are available in edge locations. A really good example of that is DNS. So Amazon's Route 53 is a rock-solid DNS service that has an SLA of 100%. Amazon will always have DNS up and running. And guess what? DNS is crucial, first, to the performance of your application, and second, to the availability of the application. Because if you have a great data center, even outside of cloud, and that data center fails, and your DNS isn't properly configured to fail over, or DNS isn't properly configured to route or to resolve, then no matter how great your infrastructure is, that little piece called DNS could be your Achilles heels, right? So DNS is crucial. Now, everywhere there's an edge location, Amazon has essentially a DNS server, just to simplify things. So if you were looking for a DNS to complement your environment, whether you're using Amazon Web Services, the cloud offering, or if you just want to use Amazon Web Services just for DNS, you can just buy DNS from them. You can have a DNS presence in every one of these blue dots, which means, to simplify it, if you have an e-commerce site and your users in Australia are trying to resolve that site, instead of that resolution going all across to the US in order and hit a DNS server to be resolved, and then point it to your IP, it can hit any one of those DNS servers that are closer to it, resolve to your website, and give your users quicker access. So your page is going to load a lot quicker that way. So DNS is an example of the type of things that Amazon uses at edge locations. It'll also have web servers for delivery of web services faster, so on and so forth. But the idea here is edge locations are not locations where you can place workloads, but they're locations where you can consume some of the Amazon Web Services offerings that are available there, for example, DNS. Now, I'm sure you're curious about an overview of regions, availability zones, edge locations, etc. There are 10 regions in all that Amazon Web Services offers. And then you have GovCloud. So technically, there are 11 regions, except the GovCloud region is a cloud that is specifically for government entities. So if you don't work for a government branch, then you cannot take advantage of the government cloud. You cannot place your resources in the GovCloud region. It's specifically for government, US government in this case. So there are 10 other regions where you can place your workloads in. There are several availability zones and several edge locations. This particular website, the AWS Global Infrastructure, gives you an idea about where those 10 regions are, how many availability zones within every region, the edge locations, and some of the features and services available in every region. Let's take a look real quick. So for example, if we take a look at North America, you'll find that you have 3 regions here, and then you have the GovCloud, right? So US East, you'll find that it has 5 availability zones within US East. And it'll give you when it was launched. So it was launched in 2006. This was the very first region that AWS presented. And because it's such an old region, not old from as a bad thing, but old from a reliability, it's been up the longest. Typically, the US East is where Amazon will launch all of the newer services. All of the newer offerings will be started there first. Now, if you look a little closer at US East, you'll find that there are 5 availability zones. But if you dig a little deeper, you'll notice that maybe there are only 3 availability zones where you can place workloads. That leaves 2 other availability zones, and you're probably thinking, well, why can't I use the other 2 availability zones? There are several explanations. Either it's being phased out, some of the availability zones are being phased out, or maybe there are availability zones that are being introduced, but they're not ready yet. So maybe they're building a data center, but it's not ready for prime time. So as a result, there is an availability zone, but it's not ready for workloads to be placed there. Or maybe they're phasing it out, they're decommissioning it, it's old, whatever the case is. So either they're taking it out, or they're adding new services in, or it's reached its max capacity. So maybe there's a particular data center that cannot accept any more workloads, and as a result, it's still available as an availability zone, but it's just not accepting new customers or new workloads. So there are several reasons why, if you're seeing 5 but you're only able to add workloads in 2, that's these are some of the explanations that you can get. Now you can scroll down the list again and take a look. For instance, in South America, Sao Paulo, they'll have 2 availability zones again there, and you'll see that it was launched in 2011, and so on and so forth. You can keep scrolling down the list and taking a look at the global infrastructure and what Amazon has in each availability zone as far as presence and so on. Now, if you wanted to take a look at what they're offering in terms of services, what you can do is click on the See Detailed list here. So if you click on that, you'll find that it lists all of the services that they offer. And then you can go through and take a look at which service is being offered where. So you'll see that there are some gaps down here. These particular services won't be offered in those regions or in the availability zones. You can also scroll down and take a look at where Amazon has AWS edge locations. Also, you'll see all of these in North America, South America. I mean, these lists are just huge. So you could take a look. And again, one of the reasons I invite you to always check this list is because they're probably going to continue to grow. They're going to be adding more regions and more availability zones all the time. They're going to be adding more services. And before you deliver or deploy your workloads, you need to have an idea of whether or not these services are available in your region, in your availability zone, yes or no. So this would be the website to visit in order for you to make that determination. Now, with an infrastructure like Amazon or Azure or Google or etc., you're probably saying, I wonder if they build data centers the same way I do. And I thought I'd bring this to your attention because I think it's very cool. Do you know what this is? If I told you this was how Amazon builds data centers, this is essentially a shipping container that is made up of all the resources that you would have. It's a mini data center, essentially. So instead of them adding racks and stacks, etc., they bring these containers and they essentially plug them in. And these containers are full of servers, they're full of resources, storage, networking gear, etc. So on the left, you'll see that I've posted a rare picture of what Amazon calls the Amazon Predicts, which is essentially their data center in a container. And if I can imagine the Amazon data centers full of these types of containers that make up that availability zone. So if you were thinking that, hey, they build data centers the same way that we build data centers, nope. Their servers are different. Their servers are very customized. They're not even super microservers. That even they remove components from a super microserver, so they're customizing the motherboard with exactly the components that they need in order to save on power. So their servers don't necessarily come in any kind of an enclosure. So the way they build their data centers is very efficient. They're dropping these containers that have been tested, validated. These are kind of the Cadillac of a converged or hyper-converged infrastructure, right? So if you've seen or if you've used converged infrastructure, this is kind of the next evolution at the scale that Amazon needs to grow at, because it doesn't make sense for them to do this the way we do it. They need to be able to scale faster. They need to be able to control the cooling. So every one of those also has controlled cooling. So what they've done is, again, go back to that idea of a system, right? They've come up with a process, a methodology. Instead of them trying to figure out every time they add 2 new servers or 10 new servers or 50 new servers, what the airflow needs to look like, how much more air conditioning and cooling they need to do. What they do here is, because this container has a specified number of servers and storage and etc., they know exactly how much it needs to be cooled, how much power it needs, everything. They contain all of that in this container, and all they have to do then is just stack containers. It's a pretty elegant thing. Now on the right, you'll see that Microsoft also has the IT pack, which is essentially the same thing. They're doing a similar approach to what Amazon is doing, and I'm pretty sure that the Azure cloud is probably configured in this scenario as well. So this gives you an idea for how they build their data centers, the efficiency at which they build their data centers, which brings up an interesting point that I'm going to leave you with. Whenever I have conversations with customers, with friends, with colleagues, and I'm like, look, no matter how well we do data centers, no matter how well we build it, we'll never be able to get to the point that Amazon and Azure and a lot of these large cloud providers get to in terms of perfection of the process, of the system, of the way they do it. But look at this. How can you have that precision in your environment? They are very methodical. Again, it goes back to the idea of building your bike or buying the bike. Sure, you can put the components together. It'll probably not look as efficient as the one that you just purchased. There are machines that are doing it. Everything is just perfect there. So this gives you, again, an idea of how they do it versus how we do it, and why they can do it better, how they're able to save money when they do it, because again, they're customizing things, they're buying things, I don't know if I can say in bulk. They're buying them in containers, let's just put it that way. And as a result, they get a lot of synergies from that, and they're able to offer all of these cost reductions. All right, so what did we cover in this module? We started off by talking about what is elastic computing. We went in depth as far as the fluctuations, how it scales up, scales down. We gave the idea or the example of the Dollar Shave Club. And we talked about, all that wasted capacity that isn't being used, and the fact that we over provision outside of cloud, and how with cloud we can use exactly what we need. So we covered elastic computing in depth. Then we talked about regions and availability zone. We talked about the fact that a region is a geographical area, and an availability zone is essentially a data center that lives in that geographical area. We talked about the fact that Amazon has 10 regions, one GovCloud region. We talked about the fact they have availability zones and edge locations. Edge locations is where they can put services like DNS and make them available worldwide. We covered that, and I showed you a webpage where you can go and take a look at the different services that are available in every region. That being said, for Amazon Web Services edge locations, things like DNS, for example, can be placed there for a really good SLA, 100% uptime. I mean, you can't beat that when it comes to DNS. Finally, I hope this module was very informative for you, and I'd like to thank you for viewing.